So it's at the top of the hour. Oh yeah, and Meek Echo now understands that I can talk to it. Welcome everybody to the last session slot in the IETF 112 meeting. Unfortunately, not in a local physical location, but probably from your home and office spaces. Good morning, good evening, and maybe good afternoon somewhere in the world. This is the IoT operations meeting. I'm Henk Burkholz, I'm one of the co-chair, and Alexei, you can see on video, is also with us here. We are sharing this cool space for people to talk about the operations of IoT, the Internet of Things. And we have, I guess, actually, again, a very full agenda today. We always try to enable discussion here, but sometimes when the schedule is full, it's full. So let us go through the movements here. This session is being recorded. Please be aware of that. You are operating under the IETF node well. So everything you say here should be okay with your IPR interests. Also be nice to each other. There's an anti-harassment and code of conduct policy, of course. At the bottom of this slide, you can see a few BCPs. If you're not familiar with these, just think about if you are recorded here, this will be captured by the Internet Society and the IETF itself. Next slide is this here. So I don't have to say next slide. This is so great. Yeah, if you have some problems with this, again, there has been recent activities. There is an ombudsman that you can talk to. I don't know if I think we are a very chill crowd here, so that is probably just FYI. But if you have a problem, there's always somebody to speak to. So we are a very welcoming community here, and can deal with conflicts. Then if you're your first time here, please mute your mics. This is an auto feature of Meet Echo. Luckily, try to use a headphone to reduce feedback when you're talking to the group. And if you have other issues, I think that's the most interesting thing here. At the bottom, there's an issue tracker for the meetings that you can give some feedback on. So we have, again, our two scribes, Alexei and me, chairs, that's Alexei and me. We have not assigned a Jabber scribe. Let me look if there is somebody on Jabber. Yes, Carsten is there. And so, Michael, if you could have a look at the chat, most Jabber people are now linked into Meek Echo. So if there's something noteworthy on the chat, maybe you might be able to capture that also. Minutes are taken and can be edited and viewed by everybody live here via the link. Other meetings materials, apparently you found the Meet Echo because you're here. We have, again, full agenda. So I'm already taking up 3 minutes of my 5 minutes, and the first presentation is coming up, but I actually do not know how to pronounce that name, Bichat. Maybe you can unmute yourself already, and I can start to share your slides soon. But we also some from IETF have Nick presenting here. So Michael is a misnomer. Unfortunately, he's just the orchestrator of this presentation. Then later in the time frame, we have a framework for integrated industry networks. I think that has been highlighted already on the list, and it might be a 50-minute talk. And then Elliot will come in and talk about some midlife crisis. Of course, not his, but IoT devices have a life cycle, and in the midst of it, something might happen. So this will be our topics for today. Maybe there's some open mic at the end. I think we have a last-minute presenter that might be Roy Williams. I'm not sure if he presented some slides, but I think he has some news on how signing in the IoT might take a strong direction. So I will, when Elliot comes in, remind him that he might have 50 minutes and not 20 of these. So now let me try to share the first presentation. Which is authentication next generation networks, correct?
Yes.
And there we go.
Hello, good morning, folks. Well, some of you, good afternoon, maybe, or even good night. Yeah, I'm going to talk about hardware-based authentication. My co-author is Dirk van Hugo, or maybe the real pronunciation is Dirk van Hugo. He He is currently vacationing in somewhere in Africa, and this yours truly has to present it. Next slide, please. Yeah, what is this hardware-based IoT authentication? This is actually somebody, we are stealing from somebody. I'm going to show in next slide. The main idea comes from him. And so we, basically the next generation type of communication characterized by diverse applications, connecting in a heterogeneous environment. All sorts of technologies are going to be used and actually currently being used for in such an environment, especially 6G we're talking about, authentication models based on human intervention, 8.1x and so on, do not fit well in the next generation communication era. So what we need is hardware, what we called it hardware-based authentication, quote unquote. It could be, maybe there's a better name, we're going to find out. Is via sensing of video, audio, or gestures as a device is playing a melody or blinking red and blue, or a person just touched by seeing it from a camera. So currently there's a project, 802.11bf, sensing, wireless LAN sensing project. And we are closely following that project and very actively being pursued, basically doing wireless LAN signal to do the sensing. And so it could be a good proper framework for us, especially in the Wi-Fi enabled devices. And we saw some efforts in 3GPP trying to do the same thing using 5G or 6G signal. Next slide. Yeah, this is the reference. We got this idea from Professor Henning Schulzner. Maybe some of you know him. IEEE Future Networks webinar he gave in February earlier this year. So he talked about these things. We need new, including new devices into a home personal network for these types of scenarios. Should I admit a smart teapot blinking red and blue? Here's a list of device manifests, add them to the network. Admit the device I just touched. Blinking device, admit the blinking device I'm pointing the camera at, so it's very high level scenarios. Admit the device playing a melody. Okay, next. Now what we need, key technologies, do we have them in place? Wi-Fi sensing is being worked out, and we could probably have a 5G, 6G sensing also, and these are being worked out. And the other one is, I think we need AI or neural network models that will take this raw sensing data and is going to generate higher level things we are looking for. So, and there's a lot of work going on here also. Actually, in our draft, we mentioned many papers doing work in these, also enough references about Wi-Fi sensing project and all that. So I suggest you look and you check with our draft. Yeah. And so, of course, we need also the proofing, making sensing resilient to proofing and adverse channel conditions present in the presence of noise and interference from other technologies. This is, I guess, an IEEE work, and it could also be embellished by IETF work in the future as well. Next slide. Next slide. Now, again, our aim is to introduce this idea. And actually, we didn't know any similar work in IETF. We recently found out there is some, like OOB project, or there's a draft in EMU. It's quite relevant to this project. We are studying that currently. And then they have a paper, and there they have some good results about camera data processing as well. That seems to be very relevant too. So those are the things we are currently looking into. And if there's others we don't know, please let us know. So we have this draft, just to introduce the idea and also gives a lot of literature survey. And we had a mailing list, PID log, which was established before. We have re-engineered, if you might call it, to this purpose, to discuss hardware-based authentication. So we might, people who are not on that list, please join, subscribe to the list, and let's have good discussions there. And let's try to see if this work should advance in IETF. We are going to decide if really there's work needed. If it is not needed, then we just give up. I think that there is work needed. Yeah. Okay. Yeah. That seems to be it. I hope I didn't take more than 5 minutes. Any questions? I'm going to check the Jabber. I'm on Jabber. Afterwards, if you had some people had comments, I can try to reply from there.
Yeah, thank you. I already see at least Bob commenting on the chat. And are there any questions directly? Otherwise, we can move on to the next presentation. Now I unshared. Okay, that's not my intent. But next is swoosh. Here we go. Kiran, are you with us?
So I thought my slot was a little later down the line, but it's perfectly fine. I can go now.
Thank you for accommodating. The floor is yours.
Yeah, next slide, please. We kickstarted the discussion about industry IoT or industry networks and their integration with IT technologies last time in IETF 1.1. And there were two major feedbacks that we received, that we should have a framework to work on, and we should find the right stakeholders. So instead of continuing with the same document, we created a new framework-specific document just to have broader perspective. And it is at a very high level. I just want to share my mindset or thoughts, how we approach this document, and looking for feedback. And then, of course, some kind of engagement with other people in terms of reviewing, collaboration, and coordination. Next slide, please. And the motivation is pretty much the same that we talked about last time, that to what extent we can use IT technologies and integrate it with industry networks and cloudification, virtual PLC, integration of different kind of media technologies, whether they are field buses, Ethernet, or TSN. How do we integrate those together? So that's still the main motivation for this document. Can we go to next slide? And this is the high-level structure of the framework. We tried to divide the document into three parts. First thing was just to give it a name, that what it is, an integrated industry network, and describe and identify different components and interfaces that will make more sense from people who are familiar from the IETF background. And then we talk about the infrastructure, that since cloudification is one of our motivation, how do we connect multiple sites together? Or if you have certain technologies in the cloud, what kind of interfaces are required or protocols that will come into picture when you have interactions between cloud and a factory site. And for that, we leveraged the LDN nomenclature, which is defined in RFC 8799. And our main focus was just to stay aligned with industry control architecture, and that was very difficult to find. And we have also identified some kind of cooperation, how we can work with some well-known organizations and reach out to them for feedback and comments. Next slide. And it was very hard to find a good architecture, but in general, this Purdue model is quite prevalent in the industry. It talks about how industry verticals are divided into 5 levels, and how they do exchange of information from level 3 to level 4. For example, when you're going out from OT world to IT world, where you have gateways and servers, something like HMIE and MES, SCADA and SCADA, how SCADA interfaces with the IT level protocol. So there is a translation of security zones from L3 to L4. And then when you actually go up to the enterprise or business level applications, then which is normally you're in the cloud or the enterprise security zone. So there are 3 different security zones, and we wanted to preserve this model that when we build a framework, we are not jumping directly from L5 to L0. We will come up with a framework that will follow the strict order that you are taking care of the security and policies as you interface between top level to bottom level. Next slide. And we did this by using the LDN model. So a simple case will be on a site 1, I have level 0 to level 4 functions, and then it interfaces with site C, which is my enterprise zone, and it has business applications. This will have an interface like internet. And what I'm showing here is there are a lot of things happening here actually. So there is what I say BP are my boundary protocols. That if I need to move from one site to the other, what kind of interface I will need. And we don't talk all that much about enterprise zone because we already have IT technologies there. But then there is a case of cloudification. Let's say I want to host L1, L2, L3, something like virtualized PLC in an enterprise zone, and your actuators and sensors are still on the factory site. You want to have some kind of remote control. Then hopefully there is some kind of low latency infrastructure like .NET in place. So how would we interact between that? So this way we are identifying different scenarios and these interfaces, how they should work in the framework. And they need to be ironed out further, that how you will exchange the security information or how you will honor the policies that you need from L3 to L4 and L4 to L5. This is, we want to develop this further. And next slide. And this we talked about last time as well. And when I showed this picture to some of the people who are involved in the OT, they said it's extremely simplified. There are even on top of it, there's multiple layers. So there is no easier way to describe the architecture from someone who's looking into the OT. So I tend to, so I was leaning on the figure on the right-hand side. So let's not try to get into each and every minute function. This is not going to help us. So what we can do is we can stick to these interfaces, and let's not think about an end-to-end connections between L5 and L0. We can think of our disconnectivity as a segmented interface. So you will have some communication at L0 to L3, and then you honor some policies, and then so on. So you go on and build this segment. And if these issues we talked about, when I say inside protocol, this is a terminology from LDN, and this refers to our industry zone. And we talked about certain issues that today everything is encapsulated at the application level. So actual data or what your sensor, how your sensor is communicated, it is at the application level past TCP or UDP. So this way your policies are pretty, they're much larger because you have to look deeper into the packet to figure out what traffic should go where. So this is one of the issues that we could simplify in this architecture. Then I talked a lot about these zones, and firewalls are pretty stateful, and how you configure them is quite a challenge. Second thing is that most of these zones are somewhat physically separated and isolated from each other. If we talk about cloudification and softwareization, we have to think about the security model slightly differently and how we provision the firewalls. And if the scale goes up, then we cannot have firewalls with every single flow of traffic. We need to find a more aggregated or more sophisticated way of creating those policies, and maybe how the data flows on the industry floor and even to the cloud. Next. So canonical format for architecture in IT technology is that we must have a management plane, a control plane, and a data plane. So from the management perspective, obviously we should focus on some of the autonomous things, and most of the things I was thinking about is the device management, that how will you make sure that devices are well known within that management plane of that industry zone, they are onboarded, they are secure, and they are trusted. And how do you distribute policies from management plane all the way down? Control plane is very somewhat integrated with the kind of data plane we come up with. And I alluded to it last time that it will be quite beneficial to think of a data plane which is more optimized for industry networks. And obviously, it is not possible to use something like traditional IP protocols or encapsulations. It is just too intensive. And one of the problem is that we just don't have actuators and motors on the floor. Every such device has some kind of sensors associated with them. And those sensors are emitting data. The data is pretty short and the frequency is high. If we start encapsulating everything with traditional protocols, it is going to consume a lot of bandwidth, which may not be suitable. Next. So if you go deeper into this architecture, we can split the framework from three different perspectives. First part is the device side, and defining the endpoint itself will be an interesting work. For example, what is my virtual PLC? How do we identify this virtual PLC? Where, if it is somewhere in the cloud, how do I access it, or how I'm going to allow that virtual PLC to talk to my sensor? Digital twins, NMRG folks are already talking about it, so it's not that researchy from IETF perspective. And if we have to develop an instance for a digital twin for a part of the system, subsystem on the factory floor, how will we identify that? Will that be an endpoint in itself, or we represent as a network? And then physical PLCs are always attached to the sensor. So I don't, we need to decide that what are my endpoints? Is it just a sensor, or is my PLC itself is an endpoint, or is it a network node from the system perspective? And then we talked about the trust of the devices, the address assignment and management. So trust has another interesting part that I think from the industry floor perspective, we should be more concerned about the data that is coming into the device. Like I'm sending a command to change the pressure or move the motor in a particular direction. It is more important that downstream command has to be trusted than the device itself, because it's anyway on the closed factory floor, and the chances of device being compromised can only come from the command level. Next.
I'm just highlighting that you have 3 minutes left, so maybe you want to delve into some discussion or questions. Please take care of that. So moving on.
Okay. So this way I keep, the second part was identifying the network thing. And I think one good starting point will be to look at SHIC header, but I found the rule pretty, I don't know if we can use the rule ID directly, but then on top of that, we need to have some kind of communication patterns that OPC UA uses. And safety is one of the differentiating factor between IT and OT networks. So we should think about some of the solutions from the safety perspective also. Next slide. We can jump this one, next one. Yeah, so these are the three critical organizations that I thought could be relevant and we can work with. IIC, we already had a meeting. UA, I'm not sure, but it's might be relevant. And I spoke to a few people and they say that we should talk to IEEE 60802 project. They are working on some of the profiles similar to what we are working on. So this was my last slide. Thank you. So I'm looking for feedback that I'm touching on many different things. Is it the right way to go about it, or we are taking up too much, or what's the right landing spot for this kind of work? Thank you.
So anybody who wants to contribute or have questions can, of course, raise this on the list. I think the digital twin term can be specialized a little bit, but we don't have a lot of time, actually, to be honest, to really delve into this. And we want to lead the discussion at the end, yeah. So I'm sharing the next. And sorry for mixing up the agenda before. That was apparently my fault. So next up should be the names are really cool. This one.
Hi there. Can you hear me all right?
Nick, are you with us?
Hi, can you hear me?
Yes, yeah.
Perfect, great, thank you. Okay, I'll try and do this in less than 15 to give us a little time to discuss. So what I'm going to present today is work that's been ongoing within the IoT Security Foundation, and specifically under a collaborative project called Many Secured, which is looking at IoT security, but from the specific perspective of the gateway. And so within that work, sort of like we've come across a challenge that we've spent a lot of time focusing on, which is fundamentally how do we do secure, usable intranet browsing? So how do we browse local web resources, sort of like from the browser, where obviously an IoT device is essentially a special case of a local web server. And this work, I mean, there's 20 odd or so people that are sort of like dipping in and out, but the majority of it is come from sort of myself, Jan Gertzema from Signify, and Christian and Michael have been part of the discussions, who both, I believe, are on this call. Next slide, please. So yeah, fundamentally, what is the problem? So the problem is, well, you know, how within a browser can you connect securely and in brackets usably to a local intranet resource? Next slide. This is, I'm in the UK. If you go to the consumer help about how to log into BT Hub Manager, you're basically sent to 192.168.1.2.2.254, and it's an unencrypted connection. Next slide. Pretty similar if it's Vodafone. Next slide. And so the first two examples are examples of connecting to the router. But there is a large majority of IoT devices, of which like a webcam is a typical one, which pretty much give you the same instruction. Next slide. And the next ones, I think I've just pulled off a Comcast example, but again, it's a different subnet. But every single one of these user documentations is pushing you towards an unsecured web browser and insert your password and do the configuration. Next slide. So this is an example which Jan has sort of like been a bit more explicit about. This is exactly what the Philips Hue hub does in the 3 contexts, whether you enter sort of like an MDNS address that resolves, or you would enter an IPv4 address, or you enter an IPv6. You essentially got the same problem. The browser is giving a very strong indication as a user that something is not right. Next slide, please. So why is it this way? So fundamentally, from what we've seen, basically, the technology gives you an option. It can either be secure or usable, but you can't be both. Next slide. So take the example from the Philips. So this is exactly the Philips Hue hub example. So there is a certificate there, but obviously in this case, the certificate is signed by a root, and that root is Philips. But you know, what is the problem here? The problem here, of course, is the root is not signed by the approved roots in most browsers and sort of conferred by the CA browser forum. Next slide. So you won't see the animation here because it's on a PDF form. And the issue is, as a user, if you do try and put a certificate there, and we can have a discussion in a minute if you like about, well, how secure is that certificate? But you know, if there is a certificate there, it will at least allow you to encrypt. But the user's very, very strongly put off. Doesn't matter which browser you go in, you get some quite aggressive and not very usable warnings that this is not a route you should go down. And you can click around it. There's about 3 clicks through the advanced, but because it's so unusable, most manufacturers are not promoting it because bluntly it just generates loads of support calls because users are being sent somewhere and they don't understand how to deal with it. Next slide. And it's quite interesting to look at this from a slightly different perspective. So most government agencies, I know the UK IoT security recommendations, the ETSI IoT security recommendations, and there's ones from the US and the ones from Singapore, etc. They all have fundamentally the same guidance. So using the ETSI one as an example, provision 5.5 asks you very specifically, please communicate securely. Next slide. And interestingly, in a completely different section, which is on the section about don't use default passwords, there's provision 5.3.1, which says, please get the users to authenticate the device using best practice. Now, the issue here, to be blunt here, is if you're coming in from a browser, which is the norm because it's easy, just genuinely don't know what best practice is, or we haven't managed to work it out. Next slide. And saying the same thing here. So, HTTPS is best practice when trying to create a secure connection from a browser. But how do you do that? How do you do that for a local resource? How do you get the certificate on there? What does it mean? These are the fundamental sort of like problems we're trying to look into. Next slide. So, there is a solution that does work, and that's build an app. And quite a few IoT vendors and router vendors do this. And this does solve the problem because within the app, you can provision some routes that allows you to bootstrap a certificate, and the protocol might be running TLS, but the rendering UI could be HTML based or could be something else. So, but fundamentally, there is a way of actually bootstrapping that secure connection by building an app. But there are a reasonable number of reasons why that's not a good idea. Next slide. And in the white paper that I'll talk about in a minute, we've listed at least 8. But fundamentally, it's not. The way I see it, cut to the chase. I always give the example. I'm a consumer. I buy 5 light bulbs. Those 5 light bulbs come from 5 different manufacturers. If I have to install a different app to sort of like manage every single one of those devices, then something is fundamentally broken. And that's from a usability perspective. There's also all sorts of security implications. So we don't really feel this is a viable way of addressing the problem, even though it is being used in part by some of the IoT and router vendors. Next slide. So, we've been talking about the problem for a while, and we've been looking at it and seeing what we can do about it. I'm just going to do a brief sort of summary of sort of more or less where we've got to. Next slide. So we published a white paper. It's accessible on that URI. It doesn't really talk about the solution. It really is an attempt just to sort of raise the profile of the problem and try and get people's understanding about it. Because the problem a lot of us have had in this area is and I think Michael would testify to this, it takes quite a long time to convince someone there's a problem here. And so this is part of this initiative, just to sort of like raise the profile and simplify the communication such that we can start moving forward towards a sensible solution. Next slide. And just to the side, like, there's a sort of like a surface level of analysis that exists in some of the documents, but if you actually look at what is really happening at the moment, there's about 6 different classes of sort of certificate that are issued to a browser which is being used to configure. Everything from there is no certificate there, which is obviously not ideal because there's no encryption there, there's no sense of trust. The reality is a lot of them, and I've literally got them in my office at the moment, and they're the commercial bits of kit. You know, they install non-device unique certificates there, which in theory does allow you to encrypt the connection if you click through all those warnings, but there's all sorts of weaknesses there in that obviously you can spoof the certificate and copy the certificate, etc., because there's no underlying root. And then there's sort of like a gradation of sophistication of the certificate to a version 6, which is okay. This is the classic CA, it's a CA browser approved root sign certificate as you'd find on the normal intranet. But you've got to ask yourself, should we really be using that for an IT device? And then we could possibly also look at non-certificate methods of triggering this. Next slide. And so why bother? I think this really speaks for itself. I mean, why? Because fundamentally, a relatively incentivized hacker on the way that routers are currently configured and IoT devices are currently configured, it's pretty easy to get at those passwords to then attack the router. And fundamentally, as it stands at the moment, this is the antithesis of a zero trust architecture. You're basically assuming everything in the home is trusted, or indeed enterprise, using browsers the way they're currently being used in the market at the moment. Next slide. So one of the solutions, and so Christian has done sort of like the lion's share of work on this, has sort of like looked at some of the work that Plex has done this already, which is basically a method of bootstrapping the provisioning of a classic certificate to an individual device. Next slide. So Christian's done quite a lot of work on this. I mean, I put a link in there to some of his sort of like GitHub provisioning demos and just some snippets of the sequence flows that we've tried to distill from that. I think it's promising. Christian can obviously talk to detail a lot better, but there are some implementation issues specifically to do with DNS bind protection, which does call into question whether this is really the ideal solution, sort of like that can be applied at scale. But it's definitely an area to be looked at. Next slide. And then just cherry picking a few of the others that are in the provisional solutions document at the moment. So we could lobby to make some recommendations to change the browser warnings to soften them, but you've got to ask yourself the question, well, does that really fix the problem, or are we just papering over it? Next slide. And I think possibly more interestingly, I think we need to do some deep thinking about what does it mean to have that certificate on that device, and how does it get there? And maybe there's a role for the gateway or other entity on the internal network, an application, etc., to essentially be the root CA, and actually be part of both the issuing of the name and the issuing of the certificate. Next slide. And I think to some extent there may be some sort of resonance there with sort of some of the work Michael and others have done on the Brewski stuff, because it definitely is in a similar sort of field and looking at a similar approach. Next slide. So next steps. So where are we? So we published problem statements. There's a load of work in terms of requirements and sort of like soft draft solutions that we're looking to publish in the next few weeks. Just needs a little bit of polishing, and then we're also hoping to move the sort of like the underlying working model into the open and running it all off an open GitHub repo. On our side, we keep needling, certainly on the UK side, some of the government agencies to try and get their attention on it, because we think it's important, and I think the profile needs raising to create a sense of urgency about creating a solution. But then also, obviously, key to all of this is experimentation. There's a lot of work being done on actual working code to try and come up with an ideal solution to this. But I mean, I'm really exposing my own prejudices here, but I strongly suspect if we want to solve this problem properly, we sort of need to start thinking about an enhanced browser. The current browser sort of like method and the way that it's set up with the CA routes is not sufficient to solve this problem, and we might need to think about how we actually issue the address to those devices, and as well what that trust model looks like, because a certificate on a specific device that's being used to bootstrap a HTTPS session locally means something quite differently. And this is one of the reasons for bringing this subject to the attention of this group. We're really looking for more ideas and more input to come up with a better, more elegant solution to this issue. That's it. Thank you.
And thank you. And I think you sparked already a intensive discussion on the chat here. I hope this continues on the list. Please enhance your arguments a little bit with some emails to reiterate the next steps, but I have to make sure that Elliot now gets his discussion time, and for that I will squeeze Roy into all of this, and I have to find that slides. But these are only 3 slides. Cool. Hi.
So thanks, Hank. I assume everybody can hear me now.
Yeah.
So I got back from vacation, so I quickly cobbled it together. This is a hot topic at the moment for the industry at large, and it has some intersections into this space, so I thought I'd present a discussion here and ask for comments. Next slide, please. So problem space, we're working at an attempt to secure the supply chain, and the U.S. government with their executive order is kind of mandating some changes globally for all companies that want to sell to the U.S. government. And I think other governments are going to follow that pretty soon. So we're looking at a software bill of materials, and Microsoft has decided that our form of this will have signed software bills of materials ubiquitous across the company. So we're working through that. As part of this, the actual SBOM really just is basically a claim of what we produced, and you kind of need attestations and vulnerability databases to be all sucked into this, which is why there's a large discussion on infrastructure around this and how soon we can bring things up. Some of the attestation basically intersects with some of the discussion in the RATS community and some other things that are coming from Google that we need to cover over. Next slide. I really want to focus on signing in this discussion specifically. The landscape of software bill of materials is, I put IoT devices here, but it really needs to flow from firmware to services to iOS to OSs to large applications. And what is required and what's the form of these things are going to look like is still highly in flux. As part of signing, of course, we need to solve the identity. What sort of identity technology we're going to use? Is it going to be certificate based, or is it going to be DID based? And right now it's once again still in flux. So we kind of need some technology that allows us to migrate if we decide over time, because it's going to change. The requirements of IoT devices and so forth kind of put pressure on our existing technologies. Like, do we use our same PKCS7 mechanisms where we cross-sign things and generate cryptographic timestamps? I don't know whether that's a great fit in this space, and we're starting to look at other alternatives. And the lifetime brings up an interesting problem space for us. Some of our products last 10 to 15 years. In a certificate-based approach, most of the certificates we sign things with have a 5-year life cycle. So depending on the old PKCS approach, we would potentially have to cross-sign and get extensibility for the lifetime. So we're looking at different ways to solve some of those problems. Then we get into technology. We kind of figure we have a set of basic languages we need to get up and supported. And right now, if we move off of our current signing mechanisms, we're looking at 2 or 3 different alternatives. One is COSI, which is my preference at this point. The second one is JWS. And then the third one is Google's pushing a dead simple signing effort, which we're not too sure has been completely fleshed through, and we're not entirely happy with where it sits at this point. So at this point, we're proceeding with an effort to try and bring COSI up to try and hit the scale of all the OSs necessary and the scenarios that we think we have to support. That was my quick introduction. I'm willing to have discussions and feedback.
Yeah, but
on
these will have to move to the list because we squeezed you in, and Elliot really deserves his time. But I think, I think the choices you highlighted are, well, there's one that the IoT space might be very happy about. So let's see how this will work out. Please keep us updated. I'll switch to Elliot now, and he has an interesting topic. And thank you, Roy, and hi, Elliot. Sorry for the rush.
Actually, I wish we had more time to talk about Roy's topic as well. It's a very interesting topic. So thanks very much, Hank. Today, I wanted to talk about an IoT midlife crisis. So what you're looking at is actually a game that you can buy someone when they turn into their midlife. It's called Midlife Crisis. Next slide, please. So we've spent a lot of time in IoT, as we are chatting right now, doing so on onboarding, all the way on the left. We spend some amount of time on credential renewal, whether it's ACE. ACE isn't even on this slide, but you could imagine some stuff going on in ACE. We certainly have EST. There are all sorts of ways that we talk about credential renewal. And on the right side, right, people don't spend any time thinking about decommissioning, even though it's turning out to be a big problem. When I'm not even going to get to that today. That's end of life crisis, right? But just today, it's midlife crisis. I'm sort of in the middle there to talk about the transfer. Next slide, please. So, the big problem here is somebody's moving, let's say, or the device is being transferred. My favorite example is the house, though, where you're moving. And now you put in all of this lovely IoT stuff, and the next guy moves in. And how does it know? How does the next guy how is the next guy able to associate this stuff with his or her network? Next slide, please. And by the way, if people are moving in, right, you might not have the cooperation of the person who moved out. Here we have a demonstration of that where somebody got moved out, I don't know, by jumping out a window. So now that stuff, that maybe was put in by the landlord, for instance, now needs to be transferred to the next or re-owned or re-accessed by the next person. And we're talking about things like heaters, thermostats, door locks, you name it. So some of this stuff you're not going to take it with you when you go, whether it's voluntary or involuntary. Okay, next slide, please. And when the next guy comes in, you're lucky if you have the manual. Maybe you're able to, look the manual up online, right? Maybe not. But you're certainly not even going to hit, when I mentioned the reset button, if it says push the reset button, if the thing is in the ceiling, good luck, right? So finding the reset button, maybe that's not possible based on where it is. So what do, right? Next slide, please. So there are two challenges. The first is knowing that these things are in your environment already. you may not know when you move in. A perfect example might be a sprinkler system, right, which has a very conventional front-end user interface, but doesn't indicate at all that it has an IoT interface. Maybe that IoT interface is even a 3G interface, so it's not even interacting with your local network. The person was defenestrated, right, but comes back, right, because didn't get survived, and decides to play with your sprinkler system remotely, right? So these are actually some serious, issues. And worse if it's your door lock, right? Now, at least your door lock you probably will replace if you don't know how to control it, if you're smart, right? But if you don't understand the interface, who knows? So then, so it's a matter of discovering what's there and figuring out what to do with them once you've discovered them, right? Is a reset button a reasonable thing? In a consumer space, maybe sometimes. In an enterprise space, say in rented space, not at all. Next slide, please. That's it. So one of the things I'm looking for is, what does good look like? Because I'm not sure that we have a shared vision as to what good looks like in this space, particularly in the home, then in the enterprise and elsewhere. So Hank asked me to make sure this is interactive. I'm asking you, please make sure this is interactive. And with that, I'll stop.
And you have to unmute your thingy manually.
I do have a question. Have you started talking with the Smart Hub, like Smart Things and so forth? What are their thoughts in this area?
I'm just beginning to talk with them. So I've certainly talked to people like Philips before. We've talked to Siemens before a little bit in this context. And everybody has a slightly different version of this. Some people will say, for instance, in the rental market, maybe it's the owner who maintains ultimate control and manages the shift of who's allowed to access what. And in the cloud, right, that adds a whole different dimension to this problem, right? Because if that access is controlled in the cloud, transferring from one person to another, the cloud registration has to occur. So everybody's all over the map on this, from what I can gather.
Thanks, Michael.
Hi, Elliot. So thank you for actually continuing, I think last time's conversation about ownership transfer. And I think that's a really good question about good. In my mind, one of the things that good would be some kind of a protocol that allows you to collect the essentially statements of I assert control over device into a single place, so that that could be handed over by the lawyer, whether or not regardless of how the previous owner was removed. And that would be essentially a condition, that same way that you get sales, you get keys, you get other stuff through the lawyer. And if they don't give it to you, then there's issues, right? And I think that would be the interesting thing, to get that collection of statements that allow you to essentially these ownership vouchers that allow you to do things.
Where's your app?
Yep, thank you. So, very interesting problem. I think the discovery one is one of the most interesting ones, because once a device has, been left in the house and the original Wi-Fi router went away and it's no longer connected to anything, there's not much you can do there. Again, if it's a light, up above me or something like that, and I'm the new owner and I won't know, sending out a ping saying I'm lost, please, reconnect me is hard to do unless you mandate that they also go push the discovery button. Otherwise, somebody outside my house might actually, pick up and be able to control my lights, because the device was considered itself lost and let anybody register it. So that problem is in particularly a hard one to solve, and good luck.
So that was more like a reinforcement of the problem statement. Thank you. Eric? might be still on mute.
Am I up? Okay.
Ah, there you are.
I get some echo when I start talking. But, so yeah, this is an important problem, right? One can try to draw some parallels for what's going on in the physical space. And if you look at sort of getting the keys to the house, yeah, at least you know how many doors you have that have locks on them. And you can assume that the people that are selling the house are giving you the keys. There are some things that you either have to say, well, I'm going to rekey because I don't know if they had an extra copy, right? Or do you trust them that they actually gave you all the copies they had of the keys to the front door? So if you then take, well, I have these things that are stored elsewhere. Well, there might be some parallels in an apartment building that the owner of the apartment building has a master key, right? So even if somebody leaves through the window, doesn't return the keys, whatever, they can actually take care of it and take it over, right? And you could view that as, okay, should I escrow the credentials for these devices somewhere because it's an apartment building? Or should I escrow the method by which I can reset them? And how can you actually make sure that you have the whole inventory as opposed to there's some smoke detector that can remotely be triggered that you didn't actually know about. But there's clearly some unsolvable problems in this space. But I think that sort of trying to tie in with what are the use cases, because normally people don't like escrowing credentials for good reasons, but for rentals it might be the sort of only way of handling this thing. And commercial might have similar things that I want to keep track of all of my keys somewhere in a vault for my enterprise in the cloud. So wouldn't I want to do the same thing for the things that's in my factory, right? Keep them in a vault somewhere where someone else can come and pick them up. And you only have to grant access to that vault. But that clearly is probably not going to work for a consumer type thing. So interesting problem, definitely.
Thanks, Eric. So I would love to see some of the problem statements associated with the existing building blocks and gaps, but I can see Wes is in the line and Elliot has his camera on. So Wes, really quick, I think Elliot also wants to have some final remarks.
Yeah, I just had a crazy bad idea, so I thought I'd throw it out there, right? If IoT devices actually within an infrastructure were able to at least communicate with each other, that they know each other, and that's all they really need to do, then when new owner comes in, they can say, I found the refrigerator, I know it's an IoT device, and they can ask it sort of what else is around that used to be part of the previous existing network. That's a bad idea and maybe a good idea at the same time.
Thanks, Elliot.
Okay, so I think we all agree this is a problem. And I think the way that we normally do these sorts of things in this organization is we document out, what we think the world sort of looks like, sort of the scenarios of life in a consumer space. What happens when I sell my car and to somebody else, for instance? And there are opportunities here. Like cars are pretty big ticket items, so it becomes a little bit of sometimes big ticket items have easier solutions for this, whereas a thermostat might not be as big enough ticket item. So what we can do, I think, is maybe start to document this out, and I think it's probably a good use of IoT Ops actually to do just that. And to say, okay, here, start by saying, here are the scenarios, here are some of the principles we think apply in terms of solving this problem. Like, we don't really like the idea of doing some sort of key escrow, right? Because whoever's escrowing is probably not doing it well, for instance. As when we can document that out. And then once we have some principles, we might even start talking about mechanisms. I think it's a little early for mechanisms. I'd just like to get some feel for what good looks like. So what I'm looking for, I think, are a couple of co-authors to work on this, maybe even a small design team of people who would be interested. And then if we can get that going, what I propose to do is to come back to you in March with my co-conspirators at that point to say, here's what we think, here's where we think we are. Probably we'll get to the point where we've documented the scenarios. Maybe we've even got a few principles at that point, and we'll see how far we get. That's my proposal. Thoughts?
So we're at the top of the hour, but thoughts are always welcome. So if there are co-conspirators that want to speak out right now, that's a chance. But also, of course, this is something you can contact Elliot or the list with. And practically we are at the top of the hour. But I want to encourage that exact plan. So from a chair's point of view, I think Elliot is absolutely correct. This is a good space for that. And also looking at the attendee list, there might be some potential co-conspirators. Thank you all. And thank you, Elliot. Thank you all the presenters for attending here. Yeah, this was a cool IETF. It was more stressful than usual, I think. I don't know why, because I'm in the EU, it should not be so hard. But thank you all for being here in your time zones. Thank you all for attending here, and see you all in March, hopefully with some Kabbalish design team that comes up with good things.